All right, welcome to our Algebra 1 lecture. And today we were talking about representing functions. And as a reminder, a function is a relation between x's and y's in which the domain, the x values, only have one y value or range value. So let's go ahead and get started. And what we said was we have a thing called function notation. And function notation is just an easier way for us to write y and gives us a little bit more information about what numbers were put into the equation to get our answer. So, as you can see here, we use a name of a function. So we said f, and you could use any letter you wanted. And x is placed in parentheses, and we said this wasn't for multiplication. We said that this was to show what number is being substituted in, and we use that instead of the letter y. So we said this is read as the value of f of x, or f at x, or simply f of x. It does not mean a multiplication. So the normal way that we write things, or the old way that we wrote it, was in what's called XY notation. And we would write something like x equals 3x plus 2. Function notation, on the other hand, writes exactly the same thing, but it writes it as f of x equals 3x plus 2. Notice the right-hand side of the equation is still exactly the same. If we graph these on a graphing calculator or a program, we would see that they graph exactly the same. So, what we want you to do is if you see f of x, g of x, h of x, whatever the letter is, out in front of the x in the parentheses, that's just the name of the function. Remember, that function is just the rule that tells us how to get from an input x to an output f of x. So if we look at f of x equals 3x minus 2, and we want to find f of negative 4, what I'm asking you is I'm asking you to evaluate the equation f of x equals 3x minus 2 if x is substituted as a negative 4. So that's exactly what we're going to do. We're going to rewrite the function without the x's, and we said everywhere you see x, you should put parentheses. Then you should substitute in negative 4. Now, what we said was the left-hand side is now simplified. Remember, function notation is not multiplication. So, go ahead and forget about the left-hand side. Think of it as being just y. That's all f of negative 4 really is. Now go ahead and work out your right-hand side. Simplify it. We have a quick multiplication, and then we have a subtraction. So our answer is y equals negative 14, or in this case, f of negative 4 equals 14. This tells us what number went into f of x, negative 4, and what number came out after we followed our rule, negative 14. Let's look at another example. In this one we have 2x squared minus 7x. So I'm going to do the same thing. I'm going to write the function. Everywhere I see an x, I'm going to take it away and put parentheses. And then I'm going to plug negative 3 into those parentheses. The left-hand side is my x, or is my y, I'm sorry. And the right-hand side can be simplified step by step using order of operations. This is why things like Chapter 1 and Chapter 2 are so important. We're just using the rules that we learned from those two chapters. And as you can see, f of negative 3 equals 39. This basically means if you plug in negative 3 to this rule, 2x squared minus 7x, that you will get out an answer of 39. We worked 3 more examples after that, so let's do those. F of x is equal to negative 3x plus 7. We wanted to substitute in 4, so we put in our parentheses and we plug a 4 everywhere we see that. Remember, the left-hand side is simplified, so we're going to simplify the right-hand side. 3 times negative 4, or I'm sorry, negative 3 times 4 is negative 12. Negative 12 plus 7 is 5, or negative 5. Example number 2, we're going to do g of negative 21. Remember that the left-hand side is just like our y. The right-hand side, we're going to remember that a fraction, the bottom of the fraction is like divide, the top of the fraction is like multiply. So negative 21 divided by 7 is negative 3. Negative 3 times 2 is negative 6. And then we're going to subtract 4 more. In the last example, we had 2x squared plus 7x plus 2. We put in our 5. We go ahead and work our math. And we see that we have negative 13. So f of 4 is negative 5. G of negative 21 is negative 10. And h of 5 equals negative 13. Remember, this is not multiplication, so there's nothing you need to do to the left-hand side. How about if we substitute a variable instead of a number? Everything works the same. Rewrite your function. Anywhere you see x, just put parentheses. After that, plug in a minus 3 and simplify the right-hand side. The left-hand side is already done. So we use our distributive property. We combine 9 and 2, and we get 3a minus 11. G of a minus 3 is equal to 3a minus 11. Here's another one. We're going to substitute 2r in anywhere we see x. So rewrite the equation, putting parentheses instead of x's, and plug in 2r into each spot where you see an x. The left-hand side is simplified. The right-hand side, we go ahead and work out our math, and we see that we get 4r squared minus 10r, which is equal to h of 2r. Here's 2 more examples. If we substitute in a minus 2 anywhere we see x, we know that the left-hand side is done, so we're going to just leave it alone. The right-hand side will do our distributive property. Now we do our simplification. Example 5. Do the same thing. Left-hand side stays the same. We're all done with that. We multiply out, and there's our answer. Okay, hopefully this helped. Hopefully you remember that the function notation is not a multiplication. It is telling us what number to plug in for x. See you in class tomorrow.